Hello everyone, what's up? This is Han Welcome back to my channel. Tonight is such a peaceful night, but I cannot fall asleep. You know why? Because I haven't finished my homework yet. As a YouTuber, I have the responsibility to upload every week's video on time. So, let's go back to the question. Today's question is about a signal transmission system. Is somehow like a follow-up of last week's signals system. So we still have X1 and X2 as transmitter and a receiver, and between that we have noise channel. But as a follow-up, we have somehow the next step, and the next stage as a receiver and a transmitter. In each step, we have signal 0 and signal 1. All of them have two types of signal, and the probability of each signal and the conditional probability of each signal is different. In this question, we have P equals to 0 on condition xk equals to 0, and pxk plus 1 equals to 1 on condition xk equals to 0, pxk plus 1 equals to 0 on the condition that xk plus 1 is 0.3, and pxk plus 1 equals to 1 on the condition that xk equals 1 is 0.7. So the first question is asked us to calculate P2, Px2 equals to 1, which means x1 has signal 1 and signal 2 after the transmission from noise channel. The probability of x2 equals to 1. So we can do it as the same way as last week. So P probability x2 equals to 1 equals to conditional probability that x1 equals to 0 multiply x1 equals to 0 plus x2 equals to 1 and x1 equals to 1 multiply x1 equals to 1. So we just care about So we just care about the condition, no probabilities, that as long as x2 equals to 1, and it can be calculated as 0.7. But today's video we can use advanced technology as metrics to calculate the result. So we can write it as Px2 equals to 0, Px1 equals to 1. This is the result. We just put it on the left. And this is Px1 equals to 0, its probability. And this is Px1 equals to 1's probability. put it in the bracket, and we write the conditional matrix. And each one correspond to the conditional probability we mentioned before. So this is the result, which means this is the probability of x2 equals to 0, and this is the probability of x2 equals to 1. So, oh sorry, this should be the same. So we can write it as px1 equals to 0.64. Right. Let's go to the next question. The next question is talk about finding the probability of px3 equals to 1. So how to calculate the probability of x3? So x3 is the step up after x2. So we can deem x2 as a transmitter. So the x3 is as a receiver. So between x2 and x3, we still need another noisy channel. So we just need to put the result we have calculated in the first question, multiply by another transmit conditional probability matrix after that to calculate the result of question 2. I just write the result directly. Ignore the process we have calculated backward. So therefore, we can know the probability of x3 equals to 1 is such a number. So in the following question, we are about to calculate the probability, conditional probability x1 equals to 0 under the condition that we have x1 equals to 1. So it's like a backward probability. We know that x1 equals to 1. So to calculate the parent probability, we can call it that. So this question is somehow harder than the before, so it's a good question. And we need to calculate that. So firstly, we need to calculate the result P probability of x1, x3 equals to 0 and x3 equals to 1 is the result we have already calculated in question 2. Also, we need to calculate the noise channel matrix. After transmitted through it twice, we have such a transmission matrix between x1 and x3. So this is the conditional probability that px3 3 equals to 0 under the condition that x1 equals to 0. So this we know is x3 equals to 1 under the condition that x1 equals to 0. And this is x3 equals to 0 under the condition that x1 equals to 1. And this is x3 equals to 1 under the condition that x1 equals to 1. So we can use the conditional probability equation to calculate the result of this question. So we can just write the statement. We can write it as the joint state condition over x3 equals to 1. We can transfer the up one to another form. It means x3 equals to 1 under the condition that x1 equals to 0. Multiply by x1 equals to 0 over x3 equals to 1. So it's like this number. So we don't have enough space. We can just write it over there, down there. Right. So the next question is about find the limit. Find the result of pxn equals to 0 when n exceeds the limit to plus infinity. So this question is somehow to use the probability of x1 multiplied by the transformation matrix over n times polynomial n times, right? And we need to make sure that n close to plus infinity. And the result is, after calculation, the result is close to 3 over 7 and 4 over 7. And the probability xn equals to 0 is the first one. It should be 3 over 7. So that's the first question. If you like my analysis, my voice, or me, remember to sum up and subscribe my channel. I will upload the next video in the near future. Thank you.